Hey everyone, Nick Dirabertis here teaching you financial modeling. And today we're going to talk about creating data types in Python with classes. So this is part of our segment on going beyond an initial Python script, the tools and skills that we need to get to building financial models in Python. So we have already talked about data types and the basic data types that are built into Python, such as strings, floats, ints, tuples, dicts, booleans, etc. But I've also mentioned that we can also have custom data types in Python, and that is where the flexibility of Python really comes in, and that you can do basically anything with Python, and you can build all these sorts of extensions to Python. And people have put out 250,000 different packages out there which extend Python functionality, and most of that is by way of defining these classes to create new data types that you can use when you're working with Python. The class is the definition of the data type itself. So that's definitely a little bit abstract, but let's break down what the data type actually means, and it will become a little bit more concrete. So a data type in Python is just a way to describe the data which should be stored within the object and the functions which are attached to the object. And we call those methods when they're functions attached to an object. And so we define the class, and that defines the data type, and then you can create objects of that class. And so from a single class definition, a single data type, you can have as many objects as you want of that type. And so for each one of those objects, they could potentially have different data that you're passing in for that particular object, but they're going to have the same functions attached to them, the same ones which are defined within the class and attached to the data type. And while the data itself may be different, the structure of the data is going to be the same because that is also defined within the class. So again, everything in Python is an object except for just, the names of things. Those are just references back to those objects. And so we've already seen these strings, floats, ints, lists, tuples. They're just types of objects. And there are other types, other built-in types that we didn't talk about because they're not going to be, very useful for the things that we're doing, or at least, at the level of Python that we're going to explore in this class. There's definitely a few that would be useful, but are just more advanced to use. But we're not limited to just using those built-in types, right? There are these custom types. You can, import a package which is going to have its own custom types, and you can just use those and benefit from the functionality that they built out. Or you can define your own class and associated data type and use it for your own model or program. So again, the class defines the type of the object. And then we can create as many objects as we want of that type. So the class definition is going to say what type of data we need to pass in to create an object of that data type. And then we also, on that class, define the functions or methods which should go along with that type of object. And then every object we create of that type is going to have all those functions. So it can be a nice way to organize your code so that it can easily be reused. So to make this a little more concrete, thinking about the list, that's a data type we're already familiar with, we've already worked with. So in the list, we might have one list that has 1, 2, 3, and another list that has ABC, right? We constructed them both in the same way. They're both expecting to receive this sequence of different objects. And so, the class definition for lists that's in, Python's source code, says that we should pass it some kind of sequence of items, and that's going to become, just an ordered structure in the list. But then every single list that we work with, we can do a dot append, and that will add into the list, right? It adds an item onto the list. So no matter if it's the 1, 2, 3 list or if it's the ABC list, either one we can append on it. Just anything that's a list, we can do an append on it. And that's because that append is defined within the class, which defines the list data type. So then looking at that, with that same kind of visualization that we looked at before, where we have one class, it defines the structure of the data and it defines the functions, and then we can create objects of that. So here list is the class. And so for the list, we have the items in the list, just this ordered sequence of items. And then it has defined the methods append, insert, pop, etc., all the other list methods that we work with. And so whether we create, a list of A and B, the strings, or we create a list of 1 and 2, they're both going to have append, insert, all the functions, but the actual items, the data is inside, is going to be different. This one has A and B, this one has 1 and 2. But they are in the same structure. They are, a sequence, an ordered sequence of items. So this concept extends to creating your own custom data types. So, let's use a car as an example, because that's, it's a very concrete thing that everybody knows about. So we can make a class for a car and make a data type for a car. And so, for a car, you think about kind of the main characteristics, right at the highest level, the make and the model are like the most important characteristics of the car, right? And so, certainly there could be other characteristics, other data, which we have within the car data type, but let's just keep it simple and say, just make and model are the two pieces of data which we're going to have in the car. And then with a car, you can drive the car, you can fill it up, add gas to it, etc. And so we can create then, two different cars here. We can create a Honda Civic by passing it Honda and then Civic. And so the make is going to be Honda, the model is going to be Civic. And that you can drive the Honda Civic, you can fill up the Honda Civic. Or we could create the Toyota Corolla. And for that, the data is going to be different, though it will be in the same structure. It is going to have a make, it is going to have a model. It's just going to be different values for each of those. And we are going to be able to drive it, we are going to be able to fill it up, etc. So again, the functions come universally to all the objects, and the data structure is going to come, but it's going to be different actual values in the data depending on how we created the object. So let's just say we have this car class defined elsewhere. So we're going to import that car class. And so this can be as simple as just, a Python file in the same directory as your notebook. Then you would be able to import like this. Or it could be from some external package which you've installed. Then you can also import like that if this was the name of the package. But the main idea is we're getting the car class, even though we didn't define it, in this particular session directly. So then we can create the car, and calling a class to create an object of that data type looks just like calling a function. You put the name of the class and then open parentheses, and then you pass whatever inputs and then close parentheses, and that's going to make the object. So if we print that out, then we can see that it prints as a car. And then if we check the type, we can see that the type is a car type inside the car example module. And then if we check the make of this Honda Civic, we get Honda. And if we call the drive method, then we're going to see that it's driving away. So again, calling any function, we got to do open close parentheses to actually call that function, in this case a method. So it's generally a little bit more advanced to construct your own classes, your own custom data types. That's not where we're going to be focusing in this course. I would definitely encourage you to learn about that. It's very useful. I certainly apply it all the time. But it's just, one of those things where if this was a 2-semester course, I would be happy to spend time on this. But we have very limited time. We got to make sure to get all the financial modeling material in. And so we can't spend a bunch of time on, more generally useful programming concepts. So definitely, I would encourage you to learn about that on your own. You will definitely find it useful going forward. But for the purposes of this course, you don't need to know how to do that. Now, why did we just cover this if we're not going to go and create our own custom classes? So a couple of reasons. One is just to give a better understanding of the general workings of Python. Again, everything in Python is an object. Every object has a type. We can define those types using classes. And then, when you're just calling functions or methods, sometimes we've had when it's a list, we do .append, and so it's, attached to the object, we then do a dot, and then we call a function, versus if we just define a function, then you're just calling that, open close parentheses, there's not a dot or any variable before that. So hopefully this makes a little more sense now, that when we see this kind of format is because whatever the data type of the object, the class has defined this function as a method of the data type, and so you can do dot and then the function on anything of that data type, versus a plain function is not attached to any data type, and you just call it by its name without any dot or a variable name before that. And then the one other reason which I didn't put on here is then that all these libraries which we're going to bring in and work with, they have defined their own custom classes, and so just getting a little bit more visibility into when you just import car and you use that, what is going on, where did that come from, what is this car thing? It's a class, and that defines a data type that we're going to use, so giving more visibility into how that works. But then also, there is a simplified version of classes called data classes, and we are going to directly create those. So those we're going to use to organize the inputs for our model, but we're not going to go to building, full-on just general classes in this course. You can certainly feel free to use them in your projects if you, figure out everything on your own. And I'm happy to answer questions on them, but it's just not something we're going to focus on in the course. But data classes we will. So data classes, they're a lot simpler to define than a class. And typically they're just used to kind of group data together, which is exactly what we're trying to do here. So for data classes, here's kind of the setup to define a data class. So here we do need to import it. It is built into Python, but it's there are about 30 or 40 modules or packages which are built into Python, but you still need to import them. They're not just they're waiting for you to use it. You still need to import it, even though it comes with every Python. This is one of those instances. Data classes is built in, but we still got to import it. So we do this import, so we get the data class, And then this is what's called a decorator. You don't really need to worry about that. That's definitely a more advanced concept, actually, like creating decorators and understanding how they work in detail. We're not going to go there in this class. That's definitely something you can learn about on your own. Just know that you have to put this at Dataclass, @Dataclass, above the class statement, and then it's class, the keyword class, and then whatever you want the name of the class to be, and then a colon, and then just like we've seen with if statements, we've seen it with for loops, we've seen it with defining functions, we do this colon, and then after that we have indentation, and then everything indented is going to be part of this class definition. So for the data class, what we do is we define all the pieces of data which are going to be stored within this class. So we're defining that data structure of the class. And so here I'm going to say that these model inputs should have interest rates as one of the pieces of data in here, and that should be a tuple, and that's going to default to 5, 6, and 7%. And then we should have a payment as well. That's going to be a floating point number because it could have decimals potentially. And we're going to set that equal to 1,000 by default. So then we can create an instance of the inputs. So again, it's just like the functions. First you have to define the function, and then you have to use the function. Same concept with classes. First you have to define the class, then you can use the class. So here we're just setting up the definition. We're setting up this part. We haven't actually created the objects out of it yet. So to create the objects, then it looks again just like calling a function. You put the name of the class and then open parentheses, and then you pass whatever arguments, and then you close the parentheses. So here we're passing that the payment should be equal to 2,000, and we're not passing the interest rates, so those are going to take the default value of 5, 6, and 7%. So then when we print out the inputs, then we're going to see that it's an instance of model inputs. We have the interest rates 5, 6, and 7%, and we have a 2,000 payment here. And the type of that is model inputs. And we can grab those individual things out of the inputs. We can do inputs dot interest rates. That gives us 5, 6, 7%. And we can do inputs dot payment, and that'll give us 2,000. So that's the basic idea of how to create and work with data classes. So why would we want to use data classes? When are we going to use data classes? So again, it's just a convenient way to group data together. You can definitely use them for a lot more than that, but that's the most common usage and what we're going to be focusing on in this course. We just have all these different inputs. We just want to package up those inputs into a single place. And the reason that we end up going to this is because financial models typically have a lot of different inputs. We might have easily 15, 20, 30 different inputs that we need to pass in. And, what you'll find when we go with this structure of having, functions within functions and passing the data, back and forth between all the functions, if you keep everything as just individual variables, all of a sudden, every function is passing like 10 inputs to each other function, and it just becomes very tedious to be passing all these individual variables around everywhere. So by grouping it all into a single data class, we can just pass this data class around. We can pass the instance of the data class around as one single variable, and then we have access to all the inputs in every function very easily just by passing this data. So it's mainly a convenience thing. It's also going to make your code shorter in that it groups all your inputs together. So the other nice advantage of this was, again, all this data is together, and you can just, whatever the name of your instance is for the data class, you type that, and then you do dot, and then you hit tab, and you're going to see all your inputs, right? You can autocomplete all your different inputs. You have just your inputs there. You don't have all your other intermediate variables and things like that. So it's nice and convenient to work with it as well, even within the functions. So let's go ahead and look at the Jupyter example for this. So again, every data type has an associated class. So even the built-in data types, they also have classes. And so those built-in data types often have also more convenient ways to create them, but you can create them just like a normal class as well. So, you know, for strings, we've looked at creating them like this, right? Like single or double quotes automatically is going to go to a string. That's a little just, you know, shortcut Python has thrown in there for us to make our lives easier because we use strings all the time. You know, str is actually the class for string, the name of the class for string. I mean, you can see that when you check the type, it's str. And so you can also create strings by, you know, just like we looked at with car and with model inputs, you put the name of the class and then parentheses and then the data you want to pass and then close parentheses. That's going to work exactly the same way. So this would be, you know, kind of just the standard way of using any class. Here we're using it for the string. But of course, you know, the built-in data types have the more convenient ways to construct them as well. But then moving to custom classes. So, you know, here we're going to look at working with this custom car class. And if you're curious, you know, what this code looks like to create this class, we have it here in this car example.py. So it's all this stuff here. And, you know, this stuff is probably not going to make a lot of sense just looking at it. There's, you know, a fair number of things in here which take some deeper knowledge of Python to understand what's going on. So don't really worry about it. You know, if you have extra time, I would recommend reading up more on classes and learning about how this works. But it's not going to be anything that is covered in the course. So we don't really need to worry about how it's actually defined. We just want to work with it, right? So here I'm doing from car example import car, and this worked because I have car example defined in the same folder as my notebook. So if you want to run this on your own, make sure you download this car example and that it's in the same folder as your notebook in order for this to run. Otherwise, you're going to get an import error. It won't be able to find car example, and you won't be able to run this part of the code. So here we're going to make a Subaru Forester. That's going to be my car. And we can see it's coming through as a car with the make as Subaru and the model as Forester. And so now, you know, we have these methods which are attached on the data type, the class of the car. And if we hit dot and then tab, we can see what those are. And Jupyter even helps us out a little bit here with telling us, you know, what is this thing? These two are functions, right? Drive and fill up. Whereas the gas percentage, the make, and the model, those are data stored within the class. So checking, you know, make, I'm going to get Subaru, or, you know, running drive, I'm going to see that it's driving away and that the gas is now down to 40%. So if I, you know, keep driving the car here, I'm going to drive it 5 times. We can see that it drives and it takes 10% of the gas to drive, and then it drives and takes 10% more, and so on until we hit 0%. And now we are out of gas. So now when we call drive, we are just going to be out of gas no matter how many times that we drive. So that's the basic, you know, idea here. And then we can, you know, fill up the car. Now the gas is at 100, and we can start, you know, driving again until we get down to 0%. then it's out of gas, and then we can fill it up, etc. So you can give whatever kind of functionality you want to your objects, and we're going to show, or we're going to use these custom data types defined in other libraries that help us do a lot of interesting things without really understanding, how that was defined in the background. We just need to know, how can we figure out the functions on this? How can we figure out the data associated with this? And, just doing the dot tab is going to get you a lot of the way there. And then, the other main part of it is you can also just Google about whatever, custom data type that you're working with. Here I defined this car, so you're not going to find that on Google. But for any of these libraries, packages that we're going to work with, you'll be able to Google all about it. So then that brings us to data classes, where data classes are the simplified class. So, we had a lot of stuff going on here in this class, but for the data class, bam, we got 4 lines and it's done, right? It's a lot simpler to define that. So we got to have this data class import, and then we've got to do this @sign data class, this decorator. Again, you don't have to worry about what a decorator is. That's a more advanced Python thing, but you just know that you put it here for a data class, and then the very next line you want to have as the class statement. And then you have the keyword class, and then the name of the class you want to create, and then a colon, and then the indent. And then this is where you start defining your variables that are going to be attached to the class. So again, this is just like the example in the slides. We have a payment defaults to 1,000, and we have interest rates defaults to 5%, 6%, and 7%. So then, again, this is just the definition part, right? We haven't actually created any concrete object. We haven't, we don't have this data really anywhere yet. We need to create an instance of the class to get that. So here we're doing data equals model inputs open close parentheses. So again, just like functions, to create an instance of the class, you put the class name and then open close parentheses, and you can pass any arguments in here. So I could pass 2,000, and that would come for the payment. 2,000, then I could do 0.1, 0.2, 0.3 if I wanted to change the interest rates as well. Also, if you want to change them not in order, then you can specify them by name. Now it's taking the default payment of 1,000 and changing the interest rates. But you can also just do it with nothing to get the defaults for everything. And then once you have that, we can just do data dot and look at it. Well, we've got interest rates and payments are the 2 pieces of information we have associated with that data class. So we can, look up either of those individually and get that value back. So here's showing also that you can override those defaults and get that information as well. So then to show the motivation why we want to use these things, rather than just passing around the payment and interest rates themselves. So here we have a function which is going to determine, if you have an interest rate and you have a payment, what would be the principal that, got to that percentage interest rate equating to that payment. And then, does that for each one of the interest rates. So we can call that. And we call that, and we get the results we would expect. For 3% to get to 1,000 payment, that would have had to have been 33,000 principal, and if it's a 4% interest rate to get to $1,000, it would have had to have been $25,000. But you did notice that we had to pass the payment and rates separately here. Whereas if we create a data class, here we're creating the data, an instance of model inputs, and then here we pass only the data. And in here, then we do data.interest_rates, data.payment to get the same result. So the key difference here being two things. One is that we passed only a single argument here, and the other is, while you're writing this, you can go, what were my variables? Data. Oh, it's interest rates, and then use that. What was the other one? Oh, it's data.payment. Not a big difference when we only have two inputs. But you can imagine if you had 10 different inputs into, the function that runs your whole model, then all of a sudden we're passing a whole bunch of things here, and it gets pretty tedious just typing out all those separate variables each time. It might be that then your main model function, which takes these 10 inputs, then passes 5 of them to the first submodel, and then 7 of them to the second submodel, and you're just passing a lot of things in a lot of places, and it becomes tedious. Whereas here, you just pass the data everywhere, a single variable going everywhere, and then you can just use whatever you need out of that data. So quite a bit more convenient to use. So that's the basic idea with data classes, and also, we looked at using other custom classes as well, and just the whole idea of what a class is, how it relates to a data type, defines a data type. So next time we're going to come back and cover handling errors in Python, and that will be wrapping up our segment on the basics in Python that will prepare us to actually go and build out a full-on financial model in Python. So thanks for listening, and see you next time.